Welcome. My name is Terry Stringer, and today I'm going to give you a brief introduction to Stormwater Studio. I'll begin by giving you a quick tour of Stormwater Studio's user interface and then finish by demonstrating a sample project. The basic workflow is to first build a plan layout of your model, and you do this by adding lines to your system either by drawing them right on the plan, on the input grid to the right, or by importing them via land.xml or DXF files. And Stormwater Studio can handle up to 200 lines per project. And once the plan is in place, you add the associated data for each line using the input grid to the right. Lines can be circular, elliptical, rectangular, or even an open channel. And here you specify everything from pipe sizes, inverts, end values, to flow data and inlet data. What's nice is that much of this information is optional. What you leave out, the program will design for you using a host of user-defined design constraints. After that, it's just a matter of clicking a compute button and reviewing the results. Stormwater Studio offers many ways to do this, including real-time interactive tools that let you edit a variety of data items during the calculations. You'll arrive at a final design much faster than with traditional methods. But more about that later. The main part of your screen is your primary work area, which contains a series of tabs. The Plan tab is where you'll do most of your work and is where you'll create your storm sewer layout. The box on the left provides easy tools for building and manipulating your storm sewer network. The Surface tab gives you a bird's eye view of each inlet or junction in your system. And the Profile tab draws production-ready profiles which can be previewed and printed to both letter-sized or larger tabloid-sized sheets. Of course, profiles can be exported to DXF or image files. A Reports tab presents the results numerically using 3 pre-formatted reports as well as 2 custom reports. So let's go through a sample project. And whether you're modeling 33 lines or even 3, the workflow is always the same. To start a new project, just click on the File menu and select New Project. A line, by definition, is a length of pipe with a junction at its upstream end, or a length of an open channel. And there are many ways in which you can add lines to your model, but today we'll draw them right on the Plan tab. Lines should always be drawn in their upstream direction and begin at the outfall, line number 1. I'll start by clicking on the Add New Line button on the side toolbar. Next, I'm going to move my mouse cursor over to the drawing canvas and drag to draw the new line to the desired length of 50 feet and a deflection angle of 0. And notice how the length and angle are displayed on the input window to the right. If you press and hold your Shift key, the deflection angle will snap to hold degrees. Once you have reached your desired length and position, release the mouse button to accept. And don't worry if not able to drag to the exact distance. You can directly edit those values in the next step. To add the next line, simply press your mouse button again and drag to the next upstream point. In this case, 60 feet at an angle of 45 degrees. I'll just repeat this procedure for the third line. It has a length of 50 feet and a deflection angle of -45. Finish by pressing the Escape key or by clicking the OK Select button on the side toolbar. It's the one on top. You can always add more lines to an existing system by following this same procedure. Just remember to always draw in the upstream direction. Stormwater Studio will automatically number your lines in ascending order as you work upstream. Other layout tools allow you to add custom labels, zoom to the extents, insert, renumber, or delete lines, even add a DXF or image-based background map. So now that my basic layout is done, I can enter the associated data for each line. The data input window appears blank until you select a line. To select a line, click on the line itself or its junction. The selected line will turn red in color and the input window will populate with its current data. You may also select a line by clicking the downstream or upstream buttons on the bottom of the data input window, or by dragging a selection box using your right mouse button. I'll begin by selecting line 1 and working my way upstream. And note that you can enter data in any order that you wish. For example, you could start at line 3 and work downstream. It's your choice. The data input window will populate with line 1's current data. Notice the downstream line number, length, and angle are already filled in based on what we've drawn. The downstream line number is set to 0 and thus labeled as outfall. This input grid behaves very much like an Excel spreadsheet. To edit the cell, just simply double-click or press F2. Type in your data and press Enter or Tab to advance to the next cell. I'll make changes necessary to ensure the line length is 50 and the deflection angle is 0 degrees. And the line shape is circular. And tabbing down to invert elevation down, I'll enter 900.00. And this is a fixed constraint for this project, but I'll leave the pipe's rise, span, and slope at 0 to indicate I want the program to design them for me. Tabbing down to surface elevations, I'll enter 903 and 904.5 feet. You'll notice that the outfall category is open. This is because line 1 is an outfall where you'll be able to specify a starting tailwater elevation. In this case, the tailwater or starting HGL is set to begin at crown, the default. The program allows you to set any tailwater elevation you wish. However, it cannot be less than critical depth plus the diameter divided by 2. And because there are no other downstream systems in this project, the flow exiting the pipe will be sent off-site. So let's move over to the runoff tab. Its drainage area is 0.5 acres with a runoff coefficient of 0.7 and an inlet time of 10 minutes. And note that the drainage areas you specify refer only to that particular catchment. It's not cumulative. The program will add them up during the calculations. So now let's select the Inlets tab. We'll enter drop for the inlet ID, and the inlet type is a drop grate, and I'm going to set it to sag. The grate area, width, and length will be set to 2, 2, and 3 respectively. And the gutter cross slope is 0.5 feet per feet. And this is the slope that's perpendicular to the grate itself. So that's all for this line. Now we just need to repeat this procedure for lines 2 and 3. So we can select line 2 by simply clicking the upstream button. And we'll go to the Pipes tab and make sure we have a line length of 60 at an angle of 45 degrees. I'm going to leave the pipe size and invert elevations blank. This ensures the program will design them for me. And if this were an existing system, I could just enter those items in. Then tab down to surface elevation up, and I'm going to enter 906. This line has no runoff because its junction type is a manhole. So we'll go ahead and enter in an inlet ID as MH. Other than that, we can just leave things as they are and move upstream to line 3 and click on its Pipes tab. And we'll make sure we have a line length of 50 at an angle of minus 45 degrees. Again, I'm going to leave the pipe size and invert elevations blank. Now tab down to surface elevation up, also known as the rim elevation, and enter 906. Next, I'll select the runoff tab to enter the runoff data. In this case, the drainage area is 1 acre. It has a runoff coefficient of 0.7 and an inlet time of 10 minutes. Now I'll select the Inlets tab and enter data for the junction. That is head wall for the inlet ID. And the inlet type, of course, is going to be an open head wall. And that's all we need for this inlet. So now all of our input data is set and we're ready to compute results. First, I'd like to point out that you can rearrange the line IDs and inlet IDs on your plan view to better suit your individual situation. So just drag them to any desired location. And if you double click on them, that'll return to their default location. Computing your system's results is very easy. First, click on the Compute tab on the ribbon menu. And in this case, we're going to choose a 10-year return period from the drop-down list box. And for the calculation option, we'll choose the default Analysis and Design. Analysis and design calculations start at the downstream end and work upstream. Now, this method will honor any existing data and will design pipe sizes, slopes, and invert elevations that have been left out or set to 0. In our case, all the pipe sizes and inverts except for the outfall have been set for design. And the outfall invert, of course, was set to 900 feet. So now I'll click the Run button, and it's done. So let's take a quick look at the profile drawings. I'll first select lines 1, 2, and 3 by clicking on the upstream inlet of line 3 while holding down the Shift key. The program then automatically selects lines from this line down to the outfall. Alternatively, I can select lines by dragging a box around their junctions using my right mouse button. So next, I'll choose the Profile tab. And notice how the pipe sizes and invert elevations were set. Also notice that it automatically matched the pipe crowns. The hydraulic grade is shown as that blue line. And along the top of this drawing are other options for how the profile is displayed. For example, this button will toggle on or off the energy grade line. Now let's take a look at the surface charts, which are basically a plan view drawing of the inlets. The data grid along the bottom indicates the amount of flow that was captured and how much was bypassed downstream. Carryover Q is that which was bypassed by an upstream line. Use the upstream and downstream buttons on the top toolbar to navigate from one junction to the next. And to see all this in numerical form, click on the Reports tab. You can also use this tab to select multiple lines, just like we did on the plan. You do this by dragging your mouse across multiple rows, then perhaps viewing their profile. This introduction only scratches the surface of what Stormwater Studio can do, so don't be fooled by its simplicity, and always feel free to explore some other features on your own. And one such feature to explore is the Compute tab. For example, let's try recomputing the system using the Full Design option. Full Design starts at the upstream end and works downstream and always attempts to minimize the cover. And I'm going to set this option here to follow the ground surface, and then click Run. And notice how Stormwater Studio has reset the pipes to follow the ground surface at the minimum depth of cover. And as you can see, the steep slope given to line 2 resulted in a hydraulic jump. And both lines 2 and 3 are set to 18 inches. So let's explore the interactive toolbar for just a minute and see what happens when we change lines 2 and 3 to something smaller. We'll start downstream and click on line 2, and then make sure size is selected and the auto is turned on as well. And select the Results tab so we can see the numerical output while we're doing this. Then click on the down arrow once, and this reduces the 18 down to a 15. The HGL for the whole system is automatically recomputed, and you'll notice that the HGL only increased slightly. So this looks good. Now let's try taking it down to a 12-inch by clicking the down arrow again. Well, that put the energy grade line too far above the top of the pipe, so it looks like the 15-inch is a better solution. Click up to return to the 15-inch. Now let's do the same for line 3. Select line 3 and click on the down arrow. And this puts the recomputed HGL just above the crown. And that looks good. So how about a 12-inch? Well, that increased the upstream head too far, so it looks like the 15-inch is our best answer here as well. So as you've seen here, the interactive toolbar is an excellent device for fine-tuning your initial designs. And when making edits, try working from the downstream to the upstream for best results. Thanks for watching, and thanks for choosing Stormwater Studio.